Now let's continue to finish this section, the polar coordinate. So in this class, we are going to sketch the graph of the polar curve and also find the tangent to the polar curve. Okay, so let's take a look at the symmetry of the graph. So we're going to do sketch of the graph. And it's given by polar coordinate. Okay, so right now let's see symmetry. The first case, symmetry about x-axis. I'm going to show you in the graph. Okay, let's take a look. If we have a point polar r given by r theta, and if it's symmetry about x-axis, so we know the other point should be there, right? So I'm going to use different color. And what's the coordinate of that point is? That is r negative theta, right? Or what? Or we can say just this point, we can also say pi minus theta and negative r. Is that right? Okay, negative r. So we have this conclusion. If r theta is in the graph, that's on the graph, then if the graph is symmetry about axis, then the point is r negative theta or negative r pi minus theta, also less on the graph. Okay, so why we want to learn symmetry? Because when we draw graph, we don't want to draw all the pieces in the four quadrant. We just want to use the symmetry to draw the graph. Maybe you can just draw half and then use symmetry to draw the other half. That's why we want to know symmetry. Okay. The second, symmetry about y-axis. You can also draw the same thing. I like to memorize everything in the graph, or I don't want to memorize. So if we can have this graph in our mind, we can always figure this out. Same thing if we have point r theta, if it's symmetry about y-axis, so it should be there, right? And then can you see what is the coordinate for that point? That should be r pi minus theta, which is the angle, right? And O, we can also do negative theta angle, so which is there, and the negative r go back. So that means if r theta less on the graph, so r pi minus theta and negative r negative theta also less on the graph. Number 3, about origin. Same thing, draw the graph. Origin, so here if we have r theta, if it's about origin, so it should be here. So we can see the angle should be pi plus theta, right? And r. And the other way, if we use negative r, so we can just use theta. Okay, symmetry. Now let's take a look at the graph, how to sketch the graph. Example 6. Graph the curve. The curve is r equals 1 minus cosine theta. You can see in this equation, we only have r and theta. So this is the equation. This equation gives us a polar curve. We are going to plot the points. We are going to give some special value to theta and then find r in that case, we can give like several parts of r theta, and we connect those points and get the graph. Okay. But firstly, we want to see what's the symmetry of this graph. Firstly, we know this property for cosine, because here we have cosine, right? Cosine negative theta equals cosine theta. So that means what? That means r negative theta also satisfy this equation, right? R equals 1 minus cosine theta. That means this point is also on the graph. So this point is also on the graph. And we can draw the graph and see if we have r theta here, and r negative theta is also on the graph. Where's r negative theta? Just here. And then we can see what's the symmetry of this graph. So it's symmetry about x-axis. Is that correct? From the graph we can see. Okay. And now we are just going to draw the symmetry about x-axis. So we are only going to draw the upper part. And because of symmetry, we can draw the other half just by symmetry. So for theta, we don't need to choose from 0 to 2 pi. We can just choose our angle from 0 to pi because of the symmetry, right? So we are going to make a table. Why we don't choose 0 to 2 pi? Because symmetry. So here, let's draw a table. Give some value of theta, we can find some value of r. Okay. Theta, we can start from 0. And we can just give some special angle. For example, pi over 3, pi over 2, and 2 pi over 3, and just 2 pi. Okay. And let's see, r equals what? R equals 1 minus cosine theta. So 1 minus cosine, we just plug in the theta into r, find the r value. So when theta is 0, 1 minus cosine 0, which is 1 minus 1, 0. And cosine pi over 3, 1/2, and 1 minus that is 1/2. Okay, so we just find the values. And the cosine pi over 2 is 0. 1 minus 0 is 0. Here's 3/2 and 2. So you can see here we find this several, like a pair of the points, right? Several points. Now we just draw them, x and y. Okay, so you can see where is 0, 0, the first point here. The second point, pi over 3, 1/2, pi over 3, 1/2. You can see here. And pi over 2, 1, the third one, pi over 2 should be here, and the 1 roughly here. The first 3 points, right? And this is, okay, so this is 1/2, this is 1. And next point is 3/2, so larger than, roughly here. And the angle is 2 pi over 3. So it should be pi minus pi over 3. So roughly, maybe here. Okay. And for the pi, which is 2, so here's 1, 2 should be around here. And now we connect those points together. Let's see, first point, second, third. And totally we have 5 points. Okay, so we get to this. But it's only from theta from 0 to pi. We know the symmetry about x-axis, so we can just draw the other half. The symmetry. Okay, this is called cardioid. It looks like a heart, right? And you can also try the exercise, or you can do this in the homework. For cosine, it's always about x-axis symmetry. And in the homework, you will see sine. And sine, you may use this formula, identity. So you can see r pi minus theta is also on the graph. So in that case, if we have r set here, r pi minus theta should be here. So it's symmetrical but y-axis. So when you choose your angle for theta, you can choose from negative pi to pi over 2 to pi over 2. And then you draw the other half, right? So depends on the symmetry, you can see what's the difference. And then you can draw the graph by using special value of theta. And actually, the graph for this one looks like very similar to our example problem. Looks like this. So this is the sketching of the graph of the polar curve. Next, we are going to find the tangent to the polar curve. So we know the tangent is just a derivative, right? Now let's take a look at our tangent, slope of tangent. Okay. So let's see. Firstly, let's take a look at our curve given by polar equation. We write down this r equals f theta. So it's similar as the graph. We have 1 minus sine theta, r equals 6 cosine theta, those kind of thing, right? They are all like r equals f theta. So actually they give us the curve in polar coordinate. So now let's take a look at what is our x and y. X equals r cosine theta, is that right? And now if we replace r by f theta, this is x. And y equals r sine theta, and then replace r by f theta. And if you look at those two, it's like a parametric equation in terms of theta, right? With parameter theta. Then we know the derivative dy dx derivative. Do you still remember when we, in 10.2 how to calculate the derivative of the parametric equations? So here we just look them as parametric equations in terms of theta. So parameter theta. So the formula is dy dt before, right? dy dt, okay. dy over dx, which is dy dt over dx dt. But right now we change our parameter as theta, so dy d theta over dx d theta. And let's see, it becomes what? dy d theta means derivative of y. Now we look at the y function, and here is a product of two functions. We have to use product rule. F prime g plus f g prime. Okay, so that's going to be f prime theta sine theta plus f theta derivative sine, which is cosine, and the derivative of x, f prime g plus f g prime, but g prime is negative sine. So this is the formula for the derivative, but you don't need to memorize the formula. I'm going to show you how to do this in the example. Okay, you can just use the parametric equation derivative to find the slope. Let's take a look at the example. I think 7. Yeah, example 7. The polar curve is given by this function, -1 plus cosine theta. Okay. Now we are going to find the slope of tangent at parallel to. At parallel to. So first step, let's write down our parametric equations. X is r cosine theta. y is r sine theta. Right? If you want, you can also simplify, but you don't have to. You can do either way. There's no unique method. So let's see, what's the dy dx? We treat them as parametric equation. Okay, let's see, dy dx, which is dy d theta, dx d theta, which is derivative of y should be -1 minus cosine theta sine theta, f prime g plus f g prime. Okay, and the next is derivative of x, f prime g plus f g prime. And the slope, we need to evaluate the slope at pi over 2. And we know cosine pi over 2 equals 0, right? And the sine pi over 2 is 1. So when we evaluate this thing, you can just, look at all the cosine to be 0. So 0, 0, 0, 0, go away. Okay, you can just make them go away. So it becomes -1 times 1, okay, and the plus, this is also go away. So actually note that term, -1 just on the top. What's at the bottom? This term becomes 0, right? So note this term. So -1 times -1, +1, so which is -1. That's the slope. Pretty easy, right? And then if you want, you can try this exercise. So please evaluate at pi. I will give you the solution later. But in this section, you can see what we learned is all about polar coordinate summary. The first thing, the point is given by r theta. Okay, what is r? What is theta? What's the meaning? Second, what's the relationship between Cartesian and polar? Cosine theta, r sine theta. In calculus 4, you are going to use this a lot, okay? And how to find polar? R squared equals x squared plus y squared. Theta equals tangent inverse y over x. That's the relationship between them. We need to know how to switch the point and the equation from polar to Cartesian or Cartesian to polar. Switch from each other. Third, sketch the graph. And the graph is the polar curve. Number 4, slope of tangent. Okay, so in this section, we just need to know those 4 things. We can stop here.